A rubber ball of mass 0.2 kilograms is dropped from a height h. It falls from rest onto a smooth concrete floor. It hits the floor with a speed of 7.8. It then rebounds to a height of 2.5. It was in contact with the floor for 33 milliseconds. Alright, so if you look here, this is what's happening. Here is the ball, and it starts off a height h, and then it hits the ground. I'll do it like a timeline or something, I don't know. Hits the ground, and then it gets squished into the ground, and then it gets bounces back up. But when it bounces back up, it's not as high. This time it's only 2.5 meters. Now, the other thing you know, oops, where's my pen gone? There we go. Oh, the other thing you know is when it hits the floor, its speed is 7.8 meters per second, and then it's in contact with the ground for 33 milliseconds, and its mass is 0.2 kilograms. Okay. So, drop the ball, squish, bounce, and back up. So we'll look at it as three separate problems. Okay? First one is calculate the height. So if you look at this part of the journey, what's the U? What's the U? 0, good. The V? 7.8. The A? 9.81. And notice how I'm taking down as positive. And we're looking for the S. So what formula should we use here? You have 3. Which one? Now, I think the best one would be V squared equals U squared plus 2AS. So V squared equals U squared plus 2AS. The U is gone, so you get V squared over 2A would equal the S. So that would be V squared over the 2A. Yeah, 3.1 meters. So that is the answer. Yep.
7.8, when it's touch the ground or before, after?
Yeah, it's literally right before it touches the ground. And then it hits the ground, bounces, and goes back up. So, the language here is made a little bit simpler than what it would be for native speakers. So if this was maybe a native speaker level of English, it would probably say the 7.8 meters per second is the velocity of the ball at a moment instantaneously before impact with the ground. But that language is a little bit too difficult. No, it's not, Shiraz. Don't be ridiculous. Right. What vertical speed did it leave the ground at? Okay. So if you look at this part of the journey, we want to know the speed at which it left the ground at. So that would be the U, which we don't know. V is 0, good. S is 2.5. And the A? Minus 9.81 because it's slowing down. And what formula should I use? Well, no surprises here. Again, V squared equals U squared plus 2AS. AS. And I get U equal to 7 meters per second.
Is it necessary to put the minus of the gravity?
Yes, because in the second situation, you want to make sure that it's slowing down, whereas in the first one, it's speeding up. Okay, part 3 is what is the change in momentum. So that's in this part of the journey here. So the change in momentum is the momentum after minus the momentum before. Please take care with your signs. In the after picture, well, I'll just put V minus U. I'll take the M out. What's the M? 0.2. Now, the V afterwards is 7, but the U beforehand is minus 7.8, because they need to have opposite signs. One is going into the table and the other one's leaving the table. So 14.8 times 0.2. So that is 2.96 kilogram meters per second. So that was part 3. And then the last part is calculate the force when it hits the table. So what formula would be nice to use for that? Well, if you remember change in momentum, what's that called? The impulse. And you have a formula that relates impulse and F times the time is equal to impulse. So therefore F equals I over the small time. So that would be 2.96 over 0.33 times 10 to the minus 3. .7 newtons.
Newton is kg meter per second square.
Newton is kilogram meters per second square, Jeff.
NA.
Yes. Okay. You still writing that? Okay, so if you were to look at 22, the A part is kind of like what we did in question 1, part A. What is a vector? Yeah?
Magnitude and direction.
Magnitude and direction. So, let me start that one.